I'm going to stop here for just a second and see if Jessica can get in and out. Who else just showed up? Katrina, did you get an email from me telling me where your grades are right now?
Yes, I did.
Okay, good. I mean, I wanted the students to know exactly where they are, because if you know, at 3 o'clock today, I got to turn in midterm grades, and if students are not doing their homework or if they're struggling, then administration will remove them if they're not communicating with the instructor and telling them what's going on. I have students in some classes that you know, one's got COVID. You know, okay, that's a good reason for an extension where I come from. But so anyway, as long as you have, okay, and you know where you're sitting, so you're not at risk. But I do have a couple students that are at risk in here, and I wish that they would let me know what's going on. If they told me, you know, hey, I'm having trouble because, you know, car broke down and can't get to work, blah blah blah, then I can, you know, then I can try to be sympathetic. But if they just ignore me and don't do the homework and don't try to get the work done, then I have no choice but to just turn in what their grades are.
Yeah, I'm not worried. I think my grade is above where I wanted to be anyways. So.
Yeah, you're in good shape. All right. I don't know if Jessica's getting back in or not. I hope. We'll give her about 30 seconds and then we'll move on and she can. I made this problem up anyway. This is not a problem from the textbook. I'm just saying that this is the easiest problem you can come up with to find the equation. If you are given the slope and you are given the y-intercept, I'm giving the example, slope here is 3, intercept 0.7. The slope-intercept form is just the slope, the intercept, it's super easy. All right, now the one from the textbook, this is example 1. Example 1 from the textbook gets uglier. It says that given the slope is 0.7 negative and y-intercept of 0.13. And again, the process is exactly the same. Y equals slope negative 0.7x plus 13. All right, this is given to me. This is automatically the B, because I have a 0, which means I'm on the y-axis. All right, so that's the example to give in the book, super easy. Now, it gets a little more interesting. Each step we're going to get more and more interesting. Example 2 is find equation of line when you're given the slope and a point, but it's not the intercept. Find the equation of a line when given slope and point on the line, not intercept. Okay, now there's 2 ways we can do this. I'm going to do them both. I'm going to go through them fairly quickly, and so if I'm going too fast, yell at me, and if I'm boring you, then look away. All right, now I know that there's 2 ways to find the equation of a line. This is the equation of a line in slope-intercept form, and that's a wonderful way of having the equation of a line. All right, so I can either do it with the what's called the point-slope equation. I'm going to put that in red. We can use what's called the point-slope equation. Point-slope equation is y minus y1 equals mx minus x1. And then the other one is the y equals mx plus b. Both of these ways are going to find us the equation of the line with a point not on the line. So example 2 says given slope m is 5 and point of intersection is the 1/2 negative 1. All right, now I'm going to do it with the point or the y equals mx plus b form first. The textbook does this, does the point slope equation first instead of the slope intercept, but I'm going to go ahead and do the slope intercept form. Now they give me the slope. Slope is 5, so I know that y equals 5x plus some missing b. I don't know what b is. They did not give me b. They gave me a point on the line, but it's not b. All right, so I need to go and find b. Once I have slope and b, I can write my equation the same as we did up here. All right, so I'm just going to take that point, which is 1/2 -1, and I'm going to stick it into this equation, and all I'm going to be left with as a variable is b. Y is -1. -1 equals 5. X is 1/2 plus b. So now the only variable I still have is b. I have -1 equals 5 times 1/2 plus b. That's a b. All right, so now I want to get b by itself. I got 5 times 1/2. -1 equals 5/2 plus b. What I'm going to do is I need to get b by itself. I'm going to subtract 5/2 from both sides. So I'm going to go ahead and change this into a fraction. Okay, I'm going to take attendance again. Okay, so I need to subtract 5/2 from both sides. I'm going to change this into a fraction with the same same denominator. So it's -2/2, that's -1, minus 5/2 equals b. I've subtracted 5/2 from both sides, and I change this into a fraction. -2/2 minus 5/2 is -7/2 equals b. And so now I have my intercept b, and I have my slope. And so I can write the equation y equals 5x minus 7/2. Right? I'm going to move that stuff up. I'm running out of room here. So I know that with the point with m equals 5 and the intercept at 1/2 -1, using the y equals mx plus b method, I end up with y equals 5x, and we went through all this work to find out that b is -7/2 minus 7/2, and that's wonderful. Now, if we want to use the other equation, the point slope form is y minus y1 equals mx minus x1. We're given the slope is 5, and I'm going to take that point and then just substitute it in for y1 and x1. So I have y minus y1. y1 is -1, so -1 equals m, which is 5, x minus my x value, which is 1/2. Right, and the rest then is just mechanics. I have minus and minus becomes 1. Y plus 1 equals 5x minus 5/2. I want to get y by itself, so I am going to subtract 1 from both sides. Y is equal to 5x minus 5/2. I'm subtracting 1. I'm going to put it in fraction form. 2/2. Subtracting 1 from both sides, minus 2/2. And again, I get y equals 5x minus 7/2. So it doesn't matter which method I use. I can use the y equals mx plus b form. I can use the point slope form. And they both do a good job. I don't know which one is better. Some problems, this method works out better. The point slope method works better. Some methods, the slope intercept form works better. So for the rest of these examples, I'm going to do it both ways. So you can choose. I really would recommend that you go ahead and try both ways when you do the homework and see which way works better for you. And you know, if you do lots of these problems, you will start developing a feel for Sometimes one method works better and sometimes another method works better. They both do the same thing. If you've got a lot of fractions, they can both become kind of ugly. Okay, so that was example number 2. Find equation, given slope and a point. Okay, now, example 3 says, what if I'm just given 2 points? Find equation of line given 2 points on line. This is where students in beginning algebra tended to struggle the most, because this was about as sophisticated as we got. We did not really do a lot in beginning algebra with parallel and perpendicular, but we did do this. So again, going to do it both ways. Find equation of line with points Okay, this is example 3. Example 3 from the textbook, and it says use the points 2, 3 and the point -6, 1. Right, so if I'm going to use the point slope method, which is y minus y1 equals mx minus x1, or if I use the y equals mx plus b method using the point intercept, either way, the first thing I need to find is slope. So no matter which way I do this, I must find the slope. So find the slope, I use the slope intercept formula, which are the slope formula, which is m equals y2 minus y1 over x2 minus x1. So in this case, y2 is 1, y1 is 3 over -6 is y2 minus 2 gives me -1 minus 3 is a -2, and -6 minus 2 more is -8, and 2 over 8 reduces to 1/4. So there's my m. M is 1/4, no matter which way you choose to do this. Okay, so I'm going to do it, go ahead using the point slope form. Point slope form says y minus y1. Now, it doesn't matter which point you choose. You can choose either one of these points, but now we're really doing the last equation. The last equation says we gotta, if you have a slope and a point, what do? Well, now I have a slope, 1/4, and I have a point, either one of these two. I'm going to go ahead and use the first one. It's not going to matter. We're going to get the same equation, whichever point we use. Y minus y1, which is 3, equals 1/4 x minus, what's my x2? Okay, so y minus 3 equals 1/4 x minus 1/4 times -2 is 1/2. Okay, I'm skipping some steps here. If I'm skipping too much, yell at me, because again, 1/4 times -2 is -2 over 4. -2 over 4 reduces to 1/2. Okay, so now I got the equation in my line. I want to get y by itself. I need to add 3 to both sides. Y equals 1/4 x minus 1/2 plus 3, 6/2. So y is 1/4 x minus 1 plus 6, or minus 1 plus 6 is 5/2. So there's the equation of your line, y equals 1/4 x plus 5/2. If you use the point slope formula, I'm going to do the same problem here now. We're using the y equals mx plus b. We do the same work to find the slope. Now that I have the slope, I have y equals 1/4 x plus some missing b. Again, I'm going to use the first point. You could use either point, wouldn't matter. I'm just going to replace the y and the x with the values from a point on the line, and it'll tell me what my missing b must be. So I take 3 equals 1/4 x. X is 2 plus b. 3 equals 1/2 plus b. Subtract a half from both sides. I got 6/2 minus 1/2 is equal to b. And again, I get b is equal to a positive 5/2. Once I have b is 5/2, I can write the equation. Y equals my slope, x plus, and again, we got the exact same equation both ways, whichever we want to do it. Okay, so that was example 3 from the text. Find a line given 2 points. Students tended to struggle with that because there are just a few more things happening. Any questions so far? Okay, the last part of finding an equation is if I have a line and a point not on the line, how do I find the parallel line and how do I find the perpendicular line to the given line through the point not on the line? All right, so find equation of line, I'm going to use some shorthand here, line parallel and perpendicular to given line through point not on line. Okay, so in general terms, what they're saying is we have some line, we have a point not on the line, and we either need to find the equation of the line that's parallel, or we need to find the equation of the line that is perpendicular. All right, we need to be able to do both. So now parallel, what do we know about lines parallel? If lines are lines parallel lines, the slopes must be the same. Both lines must have the exact same slope. If lines are perpendicular, we know that M1 is, okay, M1, how do I want to say this? If, okay, perpendicular is M1 perpendicular to M2 means that M1 becomes a negative 1 over M1. All right, or if you want to put some actual numbers in here, it's better if you say A over B becomes negative B over A. That's a lot easier to remember than this thing. This thing is weird. When you multiply these two together, the product of perpendicular lines, the product of their slopes must equal -1. So if I take M times -1 over M, if I multiply those, I would certainly get -1 over 1. And here, A times -B is -AB over BA, and that would again reduce to -1. So parallel lines, slopes are the same. Perpendicular lines, you take the slope, whatever it is, you flip it and take the negative of it, the negative reciprocal. Okay, so let's do a couple problems. Okay, the example they're saying is, okay, find equation. Find equation of line parallel. This is example 4, line containing a point. Okay, example 4. Find equation of line containing a point 0 or -1, 3 and parallel to the given line. Okay, so find the equation of line parallel to 2x plus y equals 10 and contains point -1, 3. Okay, so I have a line, and I'm going to find another line that's parallel to that and goes through this point -1, 3. I mean, you can do this graphically, and it would be kind of fun. But, so here we go. I need to find, certainly anytime I do a line, I need to find the slope, and then I need to have a point on that line. So I need to find the slope of this line here. So I'm going to subtract 2x from both sides. Y equals -2x plus 10. I now have my slope of -2. I know in my new line that I must have the same slope. Parallel lines have the exact same slope. So I'm going to do this both with the y minus y1 equals mx minus x1. I'm going to do it with the point slope form, and I'm going to do it with the y equals mx plus b, which is the slope intercept form. I'm going to do the same thing. Okay, so I need the parallel line, and it's got to go through the point -1, 3. So I know what? I know that I have y minus, going to go through my point, 3, equals my slope, which has got to be the same, and -1. Okay, I just substituted into this equation. Y minus 3 is equal to -2x. Minus a minus becomes +1. +1 times -2 is -2. And then I need to do what to get y by itself? Y is equal to, I got to get rid of a -3, so I'm going to add 3 to both sides. -2x minus 2 plus 3 is +1. Now, doing the exact same equation, finding the exact same equation using the slope-intercept form. Again, I got y is equal to my new slope, which is -2x plus b. I'm going to substitute those values into this equation. Give me b all by itself. Y is 3. 3 equals -2 times -1 plus b. I have 3 equals 2 plus b. I want to get b by itself. I'm going to subtract 2 from both sides. 3 minus 2 is 1 equals b. That's correct. And so now I know y is -2x plus my 1. So both ways to get the exact same equation. The key here, of course, is when they say parallel lines, M1 and M2 must be the same. Okay, the next equation is we're going to do the exact same process, except we're going to find the line that is perpendicular to the line, to the given line through the point not on the line. Okay, example 5. Find equation of line containing the point 2, -3 perpendicular to line 4y minus x equals 20. Okay, so again, anytime we're going to find the equation of a line, I've got to find slope first. Once I have a slope, then I decide what I'm going to do with that slope as I create or formulate my new equation. All right, so I need to find the slope of this line here. 4y minus x equals 20. I'm going to add x to both sides. So I get 4y equals a positive x plus 20. And I'm going to divide both sides by 4. So I get y is equal to 1/4 x. 20 divided by 4 is 5. So there is this equation in y equals mx plus b form, or in point slope, or slope-intercept form. Okay, so now I've got my slope. Okay, now I want to make a perpendicular line So if this is my original slope, if M1 is 1/4, then my new line, you take this, you flip it over, and you make it negative. -4/1 or just -4. Either one's fine. Okay, so now I'm going to find the equation. This is my new slope, perpendicular slope, and I'm going to use the point 2, -3, and we're going to come up with the line that is perpendicular to the original line through the point not on the line. So if I do it with the y minus the slope point formula, y minus -3 is equal to slope, new slope, minus 4x minus 2. So y minus -3, y plus 3, y plus 3 is equal to minus 4 times x, minus 4x, minus 4 times minus 2 is plus 8. So I need to get y by itself, so I'm going to minus 3 from both sides. Y equals minus 4x, subtract 3, plus 5, really? Minus 3 minus 3 plus 5. That's interesting. Good. All right, now that's using the slope point slope form. If we use the slope intercept form, I got y equals my new slope minus 4 x plus b. I'm going to put that point in here, and I get -3 equals -4 times x, which is 2, plus b. -4 times -2, or -4 times 2 is -8. -8 equals -3 plus b. I'm going to add 8 to both sides. 5 equals b. And so my new equation is y equals -4x plus 5. And of course, they're the same. Now, if you're curious, you draw this out. My original equation was y equals 1/4 x plus 5, 1, 2, 3, 4, 5. And I got a slope of 1/4, 1, 2, 3, 4, done, 3, 4, 1. So the original line looked like this. My point is 2, -3, 1, 2, -3, 1, 2, 3. And my new equation is -4x plus 5. What's my slope here? 2, -3. -4x is my slope. My points here are way off. If you did this on graph paper, you'd come up with a nice graph where these were perpendicular. -4x plus 5, 1, 2, 3, 4, 5. And down 4/1, down 4/1. What was my, 2, -3. Yeah, this should be over here more. And it would be, again, if you did graph paper, these lines would be perpendicular. I'm just, my scaling here is so skewed that it doesn't look like they're perpendicular. But they would be if you did this on a nice piece of graph paper and had nice scale. Okay, that is, we did find a parallel line find the line parallel to the given line on the point not on the line. We did find the perpendicular line through a point not on the line perpendicular to the original line, to the given line. Okay, so we've got those two done. These are the exact examples that are used in the textbook. So if there's any confusion about what I have done, you can certainly just read through the textbook and see the exact same examples, and you can see, read through the incredibly formal vocabulary that the textbook always uses. Okay, last thing we're going to do today is going to do some applications. Applications of these linear functions. Okay, application of a linear function. Example 6. Example 6 from the textbook. Example 6 says that if I am buying a necklace made at the necklace shop or at the jewelry shop, the cost of a necklace again, you notice that this is all in English prose. You know, story problems are always the hardest because you've got to generate your own equations. Okay, cost of a necklace is $7 for the clasp and what? Clasp and crimps. I don't even know what a crimp is. So it's $7 every necklace, no matter how long it is. You've got to have a clasp, and you've got to have it crimped together to hold these beads in. And so the cost of a necklace is $7 for the clasp and crimps. In addition, cost $1.70 per inch for $1.70 per inch. Okay, so the question asks you to formulate a function. And that just means equation. Make the equation. Okay, once you've got that, now this particular question is asking you to graph it. Graph your model. All right, and then the last part is going to ask you to use your graph to find price of 30-inch necklace. Okay, so that is example 6, section or parts 1, A, B, and C. Okay, now formulate a function. Now sometimes it's very difficult to do this, so I'm just going to use some examples. I know that if I just buy the blank necklace, no beads, all right, I'm going to pay $7. So my cost is going to be $7 plus 0 times $1.70. I'm going to put $1.70 first. $1.70 times 0 extra inches. So if my necklace has 0 length, I'm going to have a cost of $7. So my cost of 0 length is $7. So that's going to go on my graph. Now I'm going to try it with if I buy a 10-inch necklace. Now I'm not going to buy a 10-inch necklace. Nobody can wear a 10-inch necklace because your neck is not going to, you know, there isn't anybody that's got a neck that's 10 inches around. But I'm just going to use that so I can get some points for my model. So I'm going to say the cost for a 10-inch necklace is what? It's $7 for the grasp and the crimps and clasp, plus I've got $1.70 for each additional inch, and I got 10 inches. So my cost for a 10-inch necklace would be $7 plus 10 times $1.70 is $17. So the cost would be $24. All right, so I know I have some points here now. I got a 0.07. I have a 10, 17. 1017, not 1017, 1024. 1024. It's always good to have 3 points. Anytime you're going to make up a graph or a model, it's good to have at least 3 points. The more points, the better. So I'm going to go way out and I'm going to say, let's do a 40-inch necklace and see how much that cost. Okay, cost for a 40-inch necklace is $7 for the clasp plus $1.70 times 40 inches at $1.70 each inch. So 4 times $1.70 is 17 for 10, 34 for 2, that's 68. 68 plus $7 is my cost for a 40-inch necklace. So I've got 40, 68, and 7 what, 85? Okay, so there's 3 points. Now, from looking at this data, we can tell what our function must be. My function must be the cost is equal to 7 plus $1.70 times the number of inches, right? So there is my function. C sub x is $7 plus $1.70 times the number of inches. So depending on my number of inches, that dictates my cost. Okay, so if there's questions on that, we can beat that for a while. Otherwise, I'm going to go ahead and graph this thing and see if it says graph the model. And most of the time you won't graph the model because they got all kinds of bad numbers. You know, if you got numbers with 500 in them and stuff, nobody wants to graph that. But we're going to graph this. Can we see my graph paper? Okay, so here I have a piece of graph paper. I turned it up, so I printed it off, and so I just I got the not the author, but the company that made the graph paper available for me. You just go online, tell it you want a piece of graph paper, how wide, how many chunks, blah blah blah. All right, so I'm going to print out. Here's my piece of graph paper. I know what cost or my okay. Now my length is my dependent variable here. The length, the length determines my cost, right? So this is like my x. Okay, and I need to put this in I need to put some scale on this, so I'm going to call this 10 inch, 20 inch, 30 inch, 40 inch, 50 inch, 50 inch. Wow, that's a big necklace. That's one that you would double, right? I mean, 50 inch is pretty good size. And then 60, blah, 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 60 inch. Okay, now my dependent variable is cost, right? This is my cost. And my cost is what? We've got a couple of values here. We've got a value of 0, 7, 10, 24, 40, 85. So I'm going to make these, I'll make this $10, $20, $30, $40, 50, 60, 70, 80, and I guess 85 will be the top of my 68 and 7 is not 85, is it? 68 and 7 is 75. All right, so let's put some points on here. What would be a nice colorful point to put on here? How about my wonderful orange pen? Okay, so I have points. I know what 0, 7 was one of my points. So here's 5, here's 6, here's 7. This is 0, 7. So that has no length, right? It has no beads on it. Its length, the length doesn't matter. It has no beads. So there's 0, 7. And I had the point 10, 24. So 10 was $24. 10.24, and I said let's do a weird one at 40.75. 40, 70, 75. 40.75. There is my model. Let's connect some points here. Okay, so there's a graph of my model. Now, the last part of the question says, use the model to find the price for a 30-inch necklace. All right, so if I go to 30 inches here, and I follow it up to where I hit, I am at where? Looks to me like I'm about 57, 58. This looks to me like it's about 30, 58. 30-inch necklace looks like it cost me about $58. All right, so that's using the model. Now, I'm going to go ahead and calculate this and make sure that my model came out right. All right. So let's calculate this thing. Cost for 30-inch should be $7. plus $1.70 times 30 inches. So my cost for 30 inch would be $7 for the clasp and crimps, plus $1.70 times 30. 17 times 3 is 51, so that's $51. And so my cost for a 30-inch necklace is going to be 50 plus 7 is $58. And that's exactly what we got on our model. We went at 30 inches, we went up and we found $58. All right? Questions? Was that fun? Was that a lot of work? What was that? No response. Have people lost interest?
It was a lot.
What? Okay, that was one example of an application. The last model, we're going to do one more application model here, and it's going to be calculating. The example is if you have a certain number of, what are those things called downtown? Farmers markets. If you have a certain number of farmers market in one year and another certain number of farmers market in another year, we can start predicting a trend of how many farmers markets are going to be in a given year. So this is example number 7 from the homework. Application says, in the year 2002, we had farmers markets. Okay, I don't know if this is in the state or in the entire nation. 3137. All right, now this is the first year that they did the study, so they're going to call this 0.0. All right, now they looked again in the year 2012, and they found out that there was 7864 farmers markets. And since this is 10 years difference, they're going to call this 0.10. All right, so here are my points for my model. I have 0, 31, 37, and I have 10, 78, 64. All right, and I'm just going to use those to come up with a model to see. First off, they're going to want me to give a function, which is easy. Function just means give me a math model, give me an equation. And then they're going to say use this to find out how many farmers markets there were theoretically, according to this data, in the year 2010. Well, 2010 is in here. We know the answer should be somewhere between 31, 37 and 78, 64. And then the last part of the question is, what year does it become 12,000? Okay, so those are the 3 questions. Question 1, A, make your model. Make model. I think they say formulate the model. Point B is what was the number of markets? I don't know. F of X equals, and then I got to find out for the year what, 2010. So I want F of 2010 equals how many? And then part C says F of what equals 12,000. And so then we're going to try and find out what is X. All right, so first off, let's make our model. Okay, our model, in order to make a model, we need to have what? Always. First thing is slope. Okay, so find my slope. Y sub 2 minus y sub 1. 78, 64 minus 31, 37 over 10 minus 0, 10 minus 0. Okay, grab your calculator, punch it out. I end up with 47.27 over 10 equals my slope. And if I divide top and bottom by 10, I get 472.7 as my slope. Now, you could leave it in this form, and that's fine, but I'm just going to go ahead and switch into the decimals because this is a real-world model. This is not something that I'm going to graph. I'm not going to graph something with a slope of 472. We're just going to do this all mechanically. Okay, so I have my slope. Once I have my slope, I can either use the y equals mx plus b form, or I can use the y minus y1 minus y1 equals x times x minus x1. I'm going to use the y equals mx plus b form to find out what b is. I know that my slope is 472.7, so I know that my line is going to look like this. Y equals 472.7x plus some missing b. All right, and I'm going to use either one of these 2 points, 0, 3, 1, 3, 7, or 10, 7, 8, 64. Either one of those I can throw in here. It's going to give me the same model. So I'm going to go ahead and use 0 because 0 is a nice number. All right, so y is what? 31, 37 equals 0 plus b. And so my b happens to be 31, 37. And we knew that because we got a 0 here. That tells me that's my slope intercept, right? So there's b. So the equation of my line is y equals 472.7x plus 3137. There's my model. You can call this f of x if it makes you feel better. All right, so now f of x equals 472.7 plus 3137. Now I need to find f of 2010. F of 2010. Now again, 2010 is what? It is 8 years after 2002. So I don't want f of 2010, I want f of 8. Right? This is the year 2010. 2010 is actually equal to 8 on our model. Okay, so f of 8 equals what? Equals 472.7x. X is what? X is 8 plus 3137. Okay, 8 times 472.7. 472.7 times 8. F of 8 is equal to 3781.6 plus 3137. So add that plus 3137, and I get 6918.6, or approximately 6919. So for the year 2010, does that, well, is that between 3137? Is that between 3137 and 7864? Yes. 6919 is right in there. Makes sense that that is for the year 8, which is 2010. All right, last question is when is f of x, when is f of x equal to 12,000? So what year can we expect there to be 12,000 farmers markets? So my model, do I have my model? My model is right there. So I'm going to erase above it here. And I know what? That when f of x equals 12,000, I want to know what x is. So I can take my model, say 12,000 is equal to the 472.7 x plus 3137. I want to solve for x. The question is, what is x? All right, so here we go. Subtract 3137 from both sides. Where's my calculator? Minus 3137 minus 3137. And I end up with 8863 equals 472.7 0.7x. I now want to get x by itself, so I'm going to divide both sides by 472.7, 472.7, and I get x is equal to x is equal to 18.749 dot 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 dot. So x is approximately 19. So that's 19 years after 2002. 2002 plus 19 years gives me 2021. So in the year 2021, we can expect the farmers markets to be 12,000. Questions? Okay, more. The PowerPoints use slightly different numbers, but they do the exact same thing. PowerPoint's really great. It's only, I think, 10 slides. So it's really worth your while to download the PowerPoint and run through it. I don't know if they do the exact same. I don't think they do the exact same modeling, but they give you an example of some data and how to make the model. In the homework says it only takes 17 minutes. So I don't think I'm stressing you too guys. I don't think I'm stressing you too much. If you're weak at this stuff, again, if I assign a homework that the students across the nation using the software takes 17 minutes to finish, if that doesn't mean you did it right. But if it takes you half an hour or even an hour to do this homework, it's a great investment, because in 2 weeks, this is the end of chapter 2. Okay, we're going to cover chapter 3 and chapter 4. I think in our midterm, our formal midterm, probably in 3 weeks. We'll have to see. I have to take a look at the syllabus and see what's going on. All right. So, any questions at all? Again, if you're, I sent out everybody's grades. If your grade is not averaging 60% as of 3 o'clock this afternoon, you will be removed from the class by administration. That is a policy set by the state of Arkansas that says that we don't want teachers investing a lot of time and effort into helping students who are struggling at this point. All right. Again, if you're less than 60 at this point, do a couple of the homeworks. I'll go make sure that some of the homeworks are open and the quiz is open, so that those that are interested can certainly catch up. All right, if there are no other questions, that is section 2.7. What do we do here on next week? Next week is what, the 13th. I think we're covering 2 sections next Tuesday. Next Tuesday, we're going to cover section 3.3, which is solving systems of equations using the elimination method. And that is an investment of time and effort, energy. And then also on Monday, we're going to cover section 3.7, which is graphing lines and inequalities. We should have done a bunch of that in beginning algebra, but then we're going to put them together and we're just going to look for areas of solution sets. But on 5.13, we cover 3.3 and 3.7. There's going to be a quiz then for this 2.7, which I just did, and 3.3 and 3.7. On 10.15, Monday, 10.15, that's next Thursday, a week from today, we cover section 4.1. 4.1 is introduction or reintroduction to polygon or polynomials. And then 4.3 and 4.4, which is the 22nd, which is 2 weeks from today, we're going to do systems of equations, eliminations, and I don't remember what 4.4 is. But then 4.5, 4.6, 4.7. So on 10/29, at the end of this month, we are going to take an exam on Proctor U. Now, if you weren't here earlier, I'm going to go ahead and show you where the it's in the same. I think it's in the same location as our start module. Well, we don't care. This video will be stored. If you go to your start module in Canvas, you click on the start module. There should be that's where all these PowerPoints are stored, and there should also be another module there that I think says videos of the class. And so this class, I'm going to, like I said, I am recording it. I'm going to save it, and I'm going to sometime around 4 o'clock after I get the grades loaded up. I'm going to go ahead and put today's video in that module. So I will repeat that to you on next Tuesday as to where it is, and I'll bring it up. I guess I can try to find it right now if my machine will let me. I always get kicked out of NWAC in the middle of class because I am not looking at the mail or stuff. Are there any questions with any of the material that we covered today? No. Okay, that is fine. Okay, let me log in here.
I just wanted to say that I couldn't find the email with my grades in it.
Okay, you do know it or you do not know it?
I do not know it. I couldn't find your email.
Really? All right. I will send that. Is this this Max?
Yes, this is Max.
All right. I will resend that to you. Unless, when everybody else leaves the class today, if you we can have a discussion then.
Oh, that'd be great.
That way, I unless you're super comfortable with me just pointing it out right now, but I would prefer to have less people chatting.
Yeah.
Oh, it looks like everybody else is gone. You're the only one that's left here, huh? All right. Okay, then nobody's going to care. I'm going to share this. If I can get my... Okay, no, looks like I got a bunch of students here, and that's fine. Okay, let me share where this video is going to be, and it's just a reminder of the PowerPoints that are where the PowerPoints are. Okay, this is NWAC website where your mail and stuff is. You go into Canvas. A little sluggish. Your different classes are coming up. Wow, this is a real dog. Okay, different classes coming up. Here is the intermediate algebra that we're in. Is it loading for me? Not yet. Okay, there is the class. Got some announcements here. I got to figure out how to get rid of those announcements. If you go to the Start Here module, you click on the Start Here. This is where the intermediate algebra PowerPoints are. You click on there and there's PowerPoints up through, I think, chapter 4. And then this is ProctorU instructions. This is where we're going to look at this when we get ready to take our midterm, because it's going to be through ProctorU. It's a little bit messed up. If you want to watch it, wonderful. But at this point, there's stuff in here that's inaccurate. But at the same location, in the same module, I'm going to try and start posting. I'll post this video. Thought there was another video somewhere else. Oh no, it's in another class. Sorry. So in this same Start module here, I will have another module here that'll have today's lesson for those that want to watch the video over. All right, let me find. Okay, Maximilian, you want me to just go ahead and give you your grade, or do you want me to send you that text email again? And if, yeah, I mean, I can, you know, I can blurt it out, but
if you could send it to me, that would be great.
all right. I will. Okay, I'm bringing up. I'm hoping you can't see this. Good. Okay, I'm bringing up the grade book for this class, and I'll tell you what you do need to look at. You are not at risk. I can tell you that much right now.
I have a quiz that I missed.
Yeah. You're not at risk, but you do. Your quiz.
Needs to get done.
Yeah, quiz R1 and quiz R711. You did not do as well on those as you should have.
Yeah.
I'll go reopen those. You are not at risk, but I will reopen those so that you can go and look at those. And also homework 2.1 and homework 1.3. You should go back and redo those.
Okay.
Yeah, you're not at risk of being purged, but I will open those things up so that you can go back, and I'll open up everything. I'll open up everything that we've had so far, all the way through the 16th. And then you can go back and you can fix those that you did not do quite as well on as you'd like.
All right. Thank you.
All right. Let's do that. Okay. Is there any other questions? Any other concerns? Okay, Grant. Can you hear me?
Yes, I can hear you.
Okay, Grant, you need to go back and do quiz 2.3, 2.4. Actually, I don't know if you did it or just did poorly on it, but you need to go back.
Yeah, I didn't do those. I had something come up and I haven't been able to be in here. That's why I kind of.
Okay.
But yeah, I can get back into those today.
Okay,
sure.
You need to get that done before 3 o'clock, because at 3 o'clock I got to turn in grades, and without that, I mean, a 0 on a test just kicks the crap out of your grade.
Yeah,
Your homework is not bad. You should do homework 2.3 and do the quiz 2.3, 2.4, and then you're going to be in good shape.
Okay.
But as of right now, because I chatted with you, you're not. I'm not going to turn you in as a potential for withdrawal or potential for administrative withdrawal. But you do need to get those two done, and it would be best if you got those done before 3 o'clock so I can give you a decent grade.
Okay.
All right.
All right.
Okay. Anyone else that has concerns or questions, something you want to chat about? Katrina knows where she is. She's doing wonderful. I got one other student that I wish had shown up today, and I'll send her an email right now saying, hey, I need some results right now. All right, that's it then. That's homework 2.7. You got the homework to do. I opened up the next homework, and if you want to look at it, that's fine. Otherwise, we are going to do 3.3 and 3.7 next time. If you remember, let me think. Yeah, we did. I think we did systems of equations and beginning algebra. So if you want to look at that and want to fight with that a little bit before I do the examples, that's strictly up to you. We are going to do systems of equations with elimination, and we are going to do system of inequalities. Both of those are going to be done next Tuesday. I suspect this class, we went an hour and 20 minutes. I suspect we will go longer. The systems of equations with elimination method is not too bad, but the inequalities is a fair amount of graphing. So you're going to want some graph paper probably in front of you when you do those homeworks and possibly even today's homeworks. All right, if there's no other questions, we're going to call her a day.
I have one more question. If I don't get these done by 3, are they not going to be able to be graded at all, or they're just going to be counted late?
2, 3, 2, 4. That is officially it's part of this grading period. I'm going to extend the time. And really, I don't count anything late. I give like a 4-day extra time to get it done. And then after those 4 days, it just shuts off. It's not like if I did it 10 days late and I only got 1/3 credit. That's not happening, right? But if you can get on those, good. Again, because I've chatted with you, I'm not gonna have you purged. But again, I do need to enter a grade. And I will review the grades just before 3 o'clock when I've got to get these grades posted. If you've redone homework 2.3 and if you've redone the quiz 2, 3, 2, 4, then I can post a decent grade. Otherwise, the grade is going to be not good. All right?
Okay.
All right.
I have a question.
Yes, ma'am.
Will the what is it, the homework assignments that are due tonight at midnight, are those going into our grades that you're putting in, or no?
No, the grading period is strictly up through 2.4.
Okay, so just the grades that you already sent in.
Yep, the ones that I sent you already. Otherwise, today or last we did 2.5, 2.6, and today we did 2.7, and if it was a semester, end of the semester, I could say, okay, last Tuesday's grades are part of the grade. But I try to give students at least a week to get stuff done, and not just get it done, but if you're done, but it's not what you'd like, to get a chance to go back and redo it and practice for maximum grade. But at this point, the grades are calculated strictly through homework 2.3 and I guess what, 2.4? Did we do 2.4? No, 2.4 we didn't do. So I'm assuming that the quiz doesn't have any questions from 2.4 because we skipped 2.4. 2.4 was a bunch of adding, subtracting, multiplying, dividing of functions, and we'll hit that hard in college algebra. We don't hit it here.
Yeah, that's why I was looking for 2.4. I cannot find it. Okay.
All right. Any other questions? Any other concerns? Okay, I mean, I am going to be here for at least until 1:50. That's my requirement to be here. If you have any questions, any kind of homework questions or any kind of questions dealing with the class in general, you can certainly shout at me, and I will be near the machine. I'll be near the, and I will be connected through Teams. So if you have questions, I'm here for you at this time. I'm going to do attendance and start writing up lessons for the next class. And I will be here available up through 1:50. If we are working on something at 1:50 and you want to get some extra help, a half hour before class and a half hour after class, I'm always available. Before class, I look at 11:30. I look to see if there's anybody here with either their hand up or with a message saying I'd like help. If there's nobody there at 11:30, I look at 11:45. And then I'm sitting here from 11:45 until I start class at 12. And again, if somebody wants help after class, I'm more than willing to just continue helping. But if there's nobody asking for help at 1:50, then I'm going to move on with my life. All right, so that is what we need to know for today.
So should I just refresh my my math lab page?
To get at the homework?
Yes.
Yeah, let me go in and make sure that that this stuff is open for you. I'm positive that 2, 3, again, there is no 2, 4, but I'm positive that 2, 3 should be open. Well, let me check.
2-3.
Yeah, because you need to do 2-3 the homework and 2-3 the quiz.
Oh, okay. And is that it then? Because it says here that 2-3 is already finished.
2-3? Okay, okay. Well, now again, if you did this today, I looked at this stuff last night, and if you did that today, then I haven't looked at it yet. But give me 30 seconds here to log in.
Quiz 4, right?
I'm sorry?
Quiz 4.
2-4, yeah. Homework through 2-4 is part of the grade here.
Because it's showing up on my page.
Okay, yeah, let me refresh mine. I'm on my laptop here. Okay, you're talking homework or quiz there?
The homework 2.3 is finished. The quiz is finished.
Yeah, okay. Your homework, I got 100% on it. I was looking at the wrong student. I'm sorry, Max.
No, you're good. I just wanted to make sure.
Yeah, nope. I appreciate your looking and looking at it. Quiz 2.3. Yeah, no, you're in good shape. No, you're good.
I was probably gonna redo quiz 5.
Quiz 2.5, 2.6. Yeah, that would be good.
Yeah.
All right. What about quiz R1, quiz R and quiz R 7R11? You did not do as well on those as you've been doing on everything else. You want to do those or no?
Yes, please. I would appreciate that.
Yep. I'm gonna open up everything for the course, and I'll make it all open until Saturday. But again, grades going at 3 o'clock. But I'll open up everything to Saturday for anybody that wants to do anything and improve.
That'd be awesome. Thank you for that.
Thank you.
All right, it'll be good. It'll be good for all. All right, I'll go back and I'll open up everything right now and make it all opened up through Saturday.
Thank you for a lot for that. Actually helps. Thank you.
Yeah.
Can do.
And just because I think for the most part, I missed the past 2 classes. Not.
I'm sorry. What's your Grant? What?
Hold on. I think it muted for some reason. I said for the most part, I think I missed the past class, and I didn't see when the midterm was. Is the midterm? I'm assuming around like Thanksgiving, or is that too early? Or